Okay. Good afternoon, everyone. I want to welcome you to the Peconic Estuary Partnership's first biennial conference titled Planning for the Next Decade. This is our third and final conference session, and it's all about habitats and wildlife. I am Elizabeth Hornstein, the Peconic Estuary Partnership State Coordinator and the lead on several habitat and wildlife restoration initiatives for the partnership. I'm really excited about the session we have planned for you today and about the great panelists we have with us today. And I just want to take a moment to thank all of our panelists, our moderators, our partners who have helped with the planning of this conference and made it possible. And I want to thank everyone on this Zoom call today for joining us. We had originally, I think, hoped to hold this conference in person, but a great thing about this virtual format is it allows even more of our partners and the public to join us and hear about the work we are doing. We have done our best to try to make this session as engaging and interactive as possible, and we'll be encouraging you to participate through the polls and the chat this afternoon. Next slide, Lauren. For those of you who may not be familiar with the Peconic Estuary Partnership, we are one of 28 national estuary programs around the country that is funded through the Environmental Protection Agency's Clean Water Act, with additional support from state and local partners. Our study area includes, goes from the headwaters of the Peconic River in Brookhaven all the way to Black Island Sound between Plum Island and Montauk Point. It also includes the land area that drains into our estuary waters, shown in orange on this map here, and this is called our watershed. And the mission of the PEP is to protect and restore the Peconic Estuary and its watershed. And we do this by bringing together partners from all different sectors, government agencies, academia, environmental groups, private industry, and the public to work together toward this common goal. Next slide, Lauren. And since the inception of the PEP, we have been working with our partners to restore habitats around the estuary. The first PEP habitat restoration plan was produced in 2000, and this described the many critical habitats within and around our estuary and prioritized sites for restoration. This plan was subsequently updated in 2009, 2017, and most recently in 2020. And since this first habitat restoration plan was published in 2000, we have completed 29 habitat restoration projects, and we currently have 15 more projects in progress. So we have been making really great strides on this front, and I just want to highlight a few of our accomplishments for you. One of our most notable accomplishments is the success we have had at restoring critical freshwater spawning and maturation habitat for our local diadromous fish species, namely the alewife and American eel. We have to date completed 2 fish passage projects on the Peconic River that restore access for these species to their historic freshwater habitat. And we have 3 more fish passage projects on this river currently in progress, which when completed will result in the restoration of over 300 acres of habitat for these fish species, which is a really great accomplishment. We have also supported the seeding of oysters, clams, and scallops in the estuary to support the restoration of our shellfish populations. And most recently, we've supported the completion of 2 living shoreline projects in the estuary, which you'll hear a little bit more about later on in this session. For more information, though, on our past and current habitat restoration work, I would encourage you to check out our habitat restoration plan, our habitat project map, and the Habitat and Wildlife page on our website. And I am going to stick those links into the chat for you right now so you can check those out. Next slide, Lauren. Despite these great successes, though, The habitats and species in our estuary still face a number of threats, from increasing development pressure, climate change, water pollution, and human use activities. So there's still a lot more work to do. And recently, the PEP updated our Comprehensive Conservation and Management Plan, which provides a roadmap for the work that PEP and our partners will carry out over the next decade. And this new management plan includes fresh goals and actions to address the most current and pressing challenges that our estuary faces. Our new management plan focuses on 4 goals: strong partnerships and engagement, resilient communities prepared for climate change, clean waters, and a healthy ecosystem with abundant, diverse wildlife. And for each of these goals, we have identified a series of objectives and actions that can be taken to help us achieve these broad overarching goals. Next slide, Lauren. So the purpose of this year's conference is really to launch this new management plan for our partners and the public, and to start discussing how we can move forward the objectives and actions that have been laid out in the CCMP and how we can put those into motion. So we've had some great discussions over the past couple of days about how we can improve water quality in our estuary, how we can combat climate change. And now today we want to talk about habitat and wildlife restoration and protection. And, you know, I think healthy habitats are really key to helping us meet all 4 of the goals laid out in our CCMP. Healthy habitats can provide water quality protection. They help increase resiliency to climate change. And of course, they support wildlife and fish species, which in turn support fishing and tourism industries and vibrant coastal communities. So I think this is a really key piece of the puzzle. And today we're going to talk about what can we do to protect and restore some of the key habitats and species in our estuary so we can achieve this overall goal of a healthy ecosystem. But before we introduce our moderator and our panelists, I first want to introduce my colleague, Lauren Scheer, PEP's Education and Outreach Coordinator. Lauren has done the majority of the behind the scenes work for this conference and has been working really hard to make sure everything runs smoothly. So if you enjoy our conference, please extend your thanks to Lauren. She has also put together a really fantastic video that highlights the importance of our work and discusses our new management plan. And so I'm going to turn it over to Lauren now to tell you more about this video and some of the logistics for the day.
Thank you very much, Elizabeth, for those kind words and the introduction. And I want to welcome everyone for coming to this session, and thank you so much for everyone's participation. It really means a lot to the Peconic Estuary Partnership. So yeah, I would like to introduce this video called the Peconic Estuary Partnership, A New Plan, A New Decade. I'm very excited to share it with you all. And it's really a culmination of some of our valued partners expressing what it means to them to be a part of this partnership, what the Peconic Estuary means to them. And it also focuses on how our new management plan, our CCMP, will carry us forward into the next decade and guide our work towards achieving the goals that Elizabeth outlined, including the goal of creating a healthy ecosystem with abundant, diverse wildlife, which is what our session is focused on today. So if you haven't gotten a chance yet, please check it out, share it with your networks. There's a lot of great footage and photos in there of the estuary, and you'll really learn a lot about who the Peconic Estuary Partnership is, where we've come from, and kind of get a great sense of the past, the present, and the future of what our estuary will look like and what we hope for it to look like. So please check that out and share it. I believe Elizabeth is putting the link in the chat for you to have easy access to it. And it's also on our website and shared through our social media platforms. And so with this video, I'd like to now jump into the flow of session for today. So thank you to those who went to Wednesday, Thursday, and today's session. And thank you to the newcomers today. So typically how these sessions flow is I will introduce our moderator in just a moment, and then we will jump into introductions of our panelists. So you can get a feel for who our panelists are and learn a little bit about them and how they connect to the Peconic Estuary Partnership. And after those introductions conclude, then I'm going to launch a poll that we would really like you to participate in. And at that poll, we'll have 4 questions for you to answer. And after the poll, then our moderator is going to jump right into the panelist discussion, where it's going to be that free form conversations amongst our panelists, where we'll be asking questions, and then they'll be answering ways that we can, what next steps can we do towards achieving that goal of a healthy ecosystem. So that will be about maybe 40 minutes, 45 minutes to 50 minutes. And then at the end of the panelist discussion, we're going to launch another poll for you to participate in, and that will have 3 questions in it. And then around 3:45, we will open up the floor for a Q&A. Where you can ask questions and our panelists can answer them. What you'll notice from the last couple of sessions and today, that we have everyone on mute just because we expect a lot of people to participate and we want to minimize distractions. So people are on mute, but we really do want to encourage you to interact with us. So feel free to use the chat at any time during the meeting. And we would like you to direct your comments and your questions to Elizabeth Hornstein directly to her, because she will be the one monitoring the chat for this session today. So in order to get your question heard or to make sure it's addressed, definitely direct it to Elizabeth. And we're going to try our best to answer all the questions that we get. And because we have a lot of people, we may miss some, but we're also try our best to contact you after this meeting if we're not able to address it today. Another note to make before we get really started is that this session is being recorded. So if you have to leave early or if someone you know couldn't make it, you will have access to this recording at a later date. And then just another note to please participate in the polls. We'd love to get your feedback throughout this conference. And now I would like to introduce our moderator for the Habitat and Wildlife session, Dr. Matthew Sclafani, who works at Cornell Cooperative Extension of Suffolk County's Marine Program. We're very excited to have you, Matt, to be our moderator for today's session. We thank you very much for being here.
Okay, great. Thank you, Lauren. Well, it's great to be here today and, talk to everybody about these important habitats and wildlife in the Peconic Estuary. And I would like to welcome everybody to this 3rd and final session of the Peconic Estuary Partnership's biennial conference. As Lauren had mentioned, I'm Matthew Sclafani. I'm with Cornell Cooperative Extension's Marine Program, which is an organization that has a long history of working with the Peconic Estuary Partnership, formerly known as the Peconic Estuary Program. So just for a little background about myself, I thought I'd just let you know what I've done. And for those of you who aren't familiar with me, I've been involved with various marine ecology research and monitoring programs that are geared towards conservation management, restoration, and enhancement of our coastal resources. I've also been involved with the Peconic Estuary Partnership for actually over 20 years now in different capacities. And I guess once upon a long while ago, I was the New York State DEC coordinator, so I have a good understanding and was involved in the first go round with this initial CCMP. And that was a very exciting and interesting time as well. I currently chair the Technical Advisory Committee, which aims to provide the best scientific guidance to the partnership for solving problems and policy. That's really the main mandate of that committee. The estuary is clearly the heart of Long Island's East End, as mentioned in the CCMP. And I just want to point out that it's also an important and vital part of its economy. The Peconic Estuary is clearly a beautiful place, I think, that supports an incredible recreational and economic opportunities for so many people. And I think we can all agree that it's important that the health of the estuary remain a top priority. And that includes keeping water quality high and the resources as abundant as possible. This is not an easy challenge to manage the health of an estuary that is affected by so many anthropogenic factors. But that is the mission of the Peconic Estuary Partnership. And it is through their efforts to engage a wide range of partners that we are actually able to improve and restore this estuary. And building consensus around the best available science of the time has always been where the Peconic Estuary Partnership has focused and has excelled. But I guess as the Beatles had once penned, it's a long and winding road. There have been some great achievements, as Elizabeth had mentioned, along the way, but there's also been some setbacks, and there are new challenges that we are facing. So it starts by bringing people together to solve these problems that are, aimed at getting at the actions in the CCMP that can be accomplished to face the many challenges ahead. The second generation CCMP, which is known again as the Comprehensive Conservation Management Plan, that was released last year, is an action plan for the management of the estuary for the next 10 years, possibly even more. And I encourage you to read this document. It forms the heart and soul of this program. It's the roadmap by which they are using to move forward through time to improve the health of the estuary. The CCMP covers a wide range of topics that include what we heard in the previous two conference sessions on water quality and also on climate change. But today, we are going to shift our focus to some of the habitats and wildlife found in and around the estuary. One of the main goals of the PEP Management Committee was to task the Technical Advisory Committee to have management actions that could be monitored to evaluate if they are working as intended. I think this is a very important goal of this new CCMP. And one of the new outcomes of the PEP CCMP will be an annual monitoring report on the health of the estuary. This will be coordinated through the PEP's Monitoring Collaborative to track key water quality parameters in the estuary that will be linked to the health of its natural resources as well. The hope overall is that when we improve water quality and other factors in stressed areas of the estuary, that we will also see favorable outcomes with the habitats and wildlife that we all want to see flourish. And through good stewardship, management, and targeted restorations and enhancements, that we will have a thriving estuary in the future for everyone to enjoy. While there are many actions in the CCMP that promote a healthy ecosystem, habitats, and natural resources, the discussion that the PEP Program Office have decided to focus around today include the following actions. So we could put the slide up here from Lauren. Basically, we're going to kind of narrow it down. There are many actions, and really, we're going to start with eelgrass. Eelgrass has been seen, some significant declines over time, and it's been viewed as a potential indicator of the health of the estuary. And we're going to talk about that. We're going to get into the monitoring and the protection of eelgrass beds, and where appropriate, if they can be restored and expanded, and that is a challenge. And that's something that we're going to hear from some of our panelists. We're also going to try to talk about using the available habitat quality assessments and climate change resiliency tools to prioritize the wetland restoration projects. Wetlands are a very important natural resource, and they have come to the top of the priority list for restoration in the estuary. And we're going to also dive into that. Some of that was discussed actually in the previous two sessions. We're going to also get into implementing the living shoreline projects. Living shorelines, as legislator Krupski highlighted yesterday, are a very important tool to soften the hardened shoreline that we are seeing increasing throughout the estuary. We're going to look at ways to monitor it and talk about its ecological and financial benefits, as well as protecting these important intertidal and shoreline habitats that are so often overlooked. Finally, we're going to get into monitoring the results of shellfish restoration efforts, share the findings, and encourage creation of shellfish spawner sanctuaries. We're going to talk about the modern approaches and the evolution of that as well. And I guess this all kind of falls under the umbrella of climate change and how they're affecting all of these natural resources and ecosystem management. This is the overarching theme that we have to work with and also evolve over time on our management strategies. So partnerships and working together are crucial to achieve these actions to reach the larger program goals. Today, we're going to hear from a great group of partners in a panel discussion to address these habitat and wildlife actions. And I'm extremely grateful that they could join us today to talk about this and hear their perspectives and their outlook for the future. Each of the panelists are going to give an overview of some of their work, and they're going to briefly highlight their thoughts on these PEP actions and the current and future needs of the estuary. So first, I'd like to start by introducing Alexa Fournier. She is the Coastal Resiliency Program Manager with the New York State DEC. The state is obviously an important partner in contributing many resources to the PEP including regulatory management and oversight, funding, and various monitoring programs. Alexa does a great deal of work with coastal resiliency in the region, which have important applications to the Peconic Estuary. So with that, I'm going to hand it over to you, Alexa, to get into your talk.
Thank you, Matt. That was a great introduction.
Thank you.
Hi, everyone. As you just heard, my name is Alexa Fournier. I'm the Coastal Resiliency Program Manager at the DEC's Marine Office located in Setauket. I wanted to give you all a brief introduction to the Division of Marine Resources and to share with you how some of our work overlaps with many of the goals of the Peconic Estuary Partnerships, CCMP, and how we are involved in these efforts. All right, next slide, please. I'll start by sharing with you our mission, and that is to manage and maintain the state's living marine, estuarine, and anadromous resources, and to protect and enhance the habitat upon which these resources depend in order to assure diverse and self-sustaining populations of these resources are available for future generations. DMR is made up of four bureaus with different focuses, but all working together to carry out this mission. We work throughout New York's Marine District, and that includes all of New York's coastal waters, including Long Island Sound, New York Harbor, and the Hudson River as far north as the Tappan Zee Bridge. Next slide, please. For today, however, I'm going to focus on the work that we do within the Peconic Bay, since I know that's why we're all here. Here are some of the fun things that DMR staff get to do in-house, or rather out in the field. Trawl surveys are done annually to look at species abundance and variety. Wetland restoration planning. This picture is up in Narrow River, which is a DEC-owned wetland in Orient that PEP and DEC are working to restore. Water samples are collected year-round to monitor bacterial levels in shellfish areas so that they can be harvested, or if the area needs to be closed, we can close them. And finally, we do field surveys of different kinds. This one in particular is done to assess some of the health of our salt marshes. Next slide, please. Of course, however, our involvement goes well beyond that, what we could do on our own in-house. DEC provides funding and support to a variety of other initiatives, including research, project implementation, and the estuary programs. Some recent examples of studies that we have been involved with. There's a study of bay scallops that was initiated following the mortality events of last season, and funding for an ecosim model of our Peconic trawl data, which will analyze critical habitats within the Peconics and see how these may be changing over time. So funding for both of these projects was awarded to researchers at SUNY SOMAS. One project that was completed recently was the development of a model to assess the ratio, which uses the ratio of unvegetated to vegetated marsh, or UVVR, to assess wetland vulnerability as a function of sediment supply. In other words, can our marshes keep up with sea level rise? This work was done by a team at USGS, and we're going to be able to use this as a tool for us to help prioritize restoration targets by better understanding how these future climate scenarios are going to impact individual wetlands in different ways. DEC has funded grants for habitat restoration projects under the Water Quality Improvement Program, or WQIP. Indian Island County Park out in Riverhead is an example of one of these projects. They are planning to restore a rather large area that was marsh at one point, and then it was filled with dredge spoil way back in the mid-20th century. And they were trying to restore that to a more natural high marsh system by increasing the connectivity with the open water. So we're very excited to get that project implemented. It's in progress, and PEP has been heavily involved with getting that one done as well. So this is just a few of the things that we do at DMR to promote healthy habitats. We're really thrilled to be able to work with groups like the Peconic Estuary Partnership to fulfill our mission and to meet with some of our shared goals.
Okay, great.
That's all for me.
All right. Thanks, Alexa. That's really great. A lot of good stuff going on at the state, and of course, incredibly important partners in this whole project. So I'd like to introduce our next panelist, who is Nicole Maher. She is a senior scientist at the Nature Conservancy in New York. Nicole implements wetland research and monitoring programs with respect to sea level rise and other anthropogenic factors to better understand their ecology and role in the coastal resiliency. And with that, Nicole, I hand it over to you.
Thanks so much, Matt. Nice to see you all today. For those who don't know me, I am Nicole Maher. I'm the senior coastal scientist with the Nature Conservancy in New York. I work primarily on our climate adaptation team, where our mantra is make way for water. And we organize our work in a hierarchy of 3 climate adaptation strategies that prioritize nature. The first is to protect and restore existing natural habitats and floodplains. The second is to move willing people and infrastructure out of harm's way and restore nature along our coasts to create buffers between the coast and development. And the third is to make infrastructure like roads that we want to keep in the floodplain able to withstand temporary inundation and pass the water that coastal habitats need to thrive. I work on parts of all 3 of these strategies, and today I want to share how my work addresses habitat protection and restoration in the context of a simple recipe for salt marsh restoration. The next slide, Lauren. Thanks. So wetland, as everyone here today knows, wetlands are vibrant and productive places. And when we think of restoration of these habitats, we're not proposing that we return to a former time point. Instead, we're restoring the natural processes that these habitats need to do all that they do for both people and nature. And in the case of salt marshes, in addition to being innately valuable, they fuel our coastal food web, clean our coastal waters, cycle nutrients, sequester carbon, provide habitat for wildlife, provide risk reduction and recreation for people, and much more. And some, as you've heard throughout this conference, healthy coastal ecosystems support healthy coastal economies and all that are dependent upon that. The next slide, Lauren. So here's my simple recipe for what salt marshes need to function today and grow vertically to continue to function into the future. And if you're looking for it, you won't find this recipe on epicurious.com. So you're going to get it here and on the recording. The first ingredient is mobile sediment. We don't have big sediment-laden river systems in the Peconic Estuary. So we need our dynamic and naturally eroding shorelines to provide sediment. Back in 2007, I started a network of marsh elevation monitoring stations in the Peconic to measure elevation trends relative to sea level rise and determine reasons for elevation shortfalls. There are now 6 stations in the Peconic, one of which is monitored by PEP, and the network has now expanded to more than 24 stations across the region with partners including DEC, Fish and Wildlife, New York City Parks, New York State Parks, and Brooklyn College, all with stations. The second ingredient is clean water. Now, salt marshes remove nutrients from our coastal waters, but they're also affected by nutrient concentrations. The monitoring system I just described is designed to help identify the different components of elevation, including the below ground component of elevation growth that's most influenced by nitrogen exposure. I also have an experiment where I'm measuring marsh response to dramatic nitrogen reduction in Western Hempstead Bay from the upgrades and rerouting of the Bay Park sewage treatment plant. And to do this, I'm using hospital CAT scans and other measures to measure how nature responds when we give it the clean water that it needs. The third ingredient in this recipe is full tidal signal. Tidal habitats are what they are and do what they do because the tide comes in and the tide goes out. And when we restrict the tides, we restrict or reduce the functions that wetland system can deliver. The Nature Conservancy has nearly completed a road stream crossing assessment in Suffolk County that identifies where undersized road crossings like culverts restrict tides. But there are also more subtle disruptions to tidal signal that have just as severe impacts, such as embankments from past agricultural practices and levees along the sides of mosquito ditches that also restrict the tides and reduce plant and elevation growth. So we're working to figure out the best restoration strategies to address these. The fourth ingredient is room to move, because marshes can't just stay in place in response to sea level rise. They also need to migrate landward to persist into the future. And PEP has developed a fantastic forward-thinking critical lands protection, or CLIPS, criteria and ranking tool to identify the best opportunities for protecting these marsh migration pathways. The final ingredient is appreciation of their value, both by the public and local municipalities. And here in the Peconic Estuary, we are so fortunate to have very engaged public and local municipalities so that they can make decisions that support the long-term viability of our marshes. And final slide, Lauren. Finally, the situation is urgent and we need to act now because both nature and people are depending on us to get it right. Thank you.
Wow, that's great. Thanks so much, Nicole. Really enjoyed that. Obviously, wetlands play a very important role in the ecosystem, and we'll be diving a little bit more into that with some additional questions and follow-up. Great picture of your daughter, by the way. I want to introduce our next panelist. Is my colleague, Stephen Schott. He is a habitat restoration specialist at Cornell Cooperative Extension's Marine Program. Steve has a long history of doing a lot of hands-on monitoring and restoration projects. You often see him out in the wetlands or in the diving gear doing the dirty work. But he's also done a lot of great work with submerged aquatic vegetation in the Peconic Estuary. He's involved with our monitoring program that tracks the health of the eelgrass, and very, very involved in this project and this program as well. Steve. Steve, you're on mute.
Thought I hit the button.
Nope.
You hear me?
Yep.
Okay, sorry.
Thanks.
Hi, as Matt said, I'm Steve Schott. I'm Habitat Restoration Specialist at Cornell. I've been working for the Cornell Marine Program for about a little over 20 years, where I started working with eelgrass, one of our two submerged aquatic rooted vegetate plants in the estuary, widgeon grass being the other. But I have a background in coastal plants and have moved into looking at shoreline, wetland, tidal wetland plants, and also moving into the coastal upland areas to look at building resiliency. Next slide. So Cornell's habitat program again works basically from coastal upland and down through the intertidal zone and into subtidal. Our shoreline, living shoreline work incorporates coastal upland and to about mean sea level, which is the downshore edge of where our salt marshes, our low marsh grows. Much of our shoreline has been modified over the hundreds of years that humans have lived on the east end, be it bulkheading and different other projects. And we're looking to help restore the functionality of these shorelines. Not, as Nicole said, we're not looking to get it back to a period in time, but try to get it to a point where it's providing the ecosystem services that we need in the estuary to keep the Peconics a healthy system. In that regard, we do work with coastal erosion and working with groups like the Peconic Land Trust to work on revitalizing shorelines by either producing or building and revegetating shorelines even above the shoreline. Again, we work on the upland coastal area, creating dunes and back dune areas. And then we also work down, as you can see in the photos, into the intertidal zone where we start to plant low marsh and high marsh plants. We were also going to be, the aerial picture in the lower right-hand corner shows Cedar Beach Creek in Southold, where Cornell's Suffolk County Marine Environmental Learning Center is located. We were going to be engaging in a almost 5-acre salt marsh restoration project to hopefully recover some of the marsh salt marsh in this system that has been lost since the 1970s. It's also the Cedar Beach facility is also the location, as Legislator Krupski mentioned yesterday, of a living shoreline demonstration area, which is the photo in the lower left, where we show basically living shorelines are using natural products like rock and wood and core logs in conjunction with plants to basically help provide some resiliency and erosion protection from those shorelines versus using straight bulkheads, revetments, concrete, and those things. The demonstration project funded by PEP and also South Old Town provides homeowners and the community to be able to come out and see what these natural alternatives would look like and whether or not they would be useful to these individual homeowners to protect their shorelines at their properties. Next slide. As I mentioned, I started with Cornell working with seagrasses, which does require a lot of being in the water and on the bottom. So we have a lot of experience seeing how in 20 years, how the estuary has changed, especially in an area below what people normally are used to seeing. We have seen since the 1930s, significant losses in eelgrass habitat in the Peconic estuary, and we still continue to see losses today. Dr. Peterson will talk about changes and trends, so I won't get too much into that. Currently, Cornell is also, I've been involved since 2000 with monitoring the remaining eelgrass meadows in the estuary for PEP, and currently we monitor 9 sites. We have some sites where we have lost eelgrass in the past, which we visit occasionally, but they are no longer part of the active system. We also have 2 active restoration sites, one located in Greenport Harbor and one located in Sag Harbor, that Cornell is working on enhancing the existing meadows that are there by doing fringe plantings along the edges to expand and increase overall area. And I think that's about it for what I do. So back to you, Matt.
Okay, great. Thank you, Steve. That's some really great, interesting work. And, you know, no doubt you've been very active in this estuary program for a very long time. So thanks for your contributions. We're going to move along now, and I'd like to introduce our next guest, who is Dr. Bradley Peterson. He's a associate professor at SOMAS of Stony Brook University. Dr. Peterson does a lot of great research on eelgrass and their ecology. Some of his most recent efforts with his graduate students have focused on eelgrass with respect to various environmental conditions in the Peconic estuary. And I guess if I were to add this, he's probably the most waterlogged faculty member at SOMAS because he's diving so much. But Brad, I'd hand it over to you now. Thanks. You're on mute, Brad.
Wow. Thank you so much. The next panelist actually 19 years ago brought me to Long Island from Miami, and Steve introduced me to the Peconic estuary and let me play with him in his scallop stuff that he did there. And so I've been in Long Island for almost 20 years playing in the seagrass beds around the area. And over those years, my students I have been interested really in kind of landscape things, restoration, ecology, plant animal types of interactions. And about 5 years ago, observations that were made by Cornell in monitoring their sites led to the next question about developing a bio-optical model to try to understand the light regime and what role that might be playing with where current grass is. And so most recently, we've been looking at what environmental parameters are really having an impact on where the grass is constrained in the Peconic estuary. Next slide, please. So Steve made mention of this map that he created, which was really looking at how seagrass has changed in within almost 100 years, how grass was throughout the Peconic estuary, and it has over the years been moving and migrating more and more to the east, to the more open and flushed areas of the estuary, which I think gives some insight into what kind of environmental parameters and mechanisms are controlling their current distribution. And so that's why I'm here today.
Okay, great. Thanks, Brad. Look forward to taking a deeper dive, no pun intended, into the world of eelgrass and some of these questions. So our final panelist, and certainly not the least of them, is Dr. Stephen Tettelbach. He is a shellfish ecologist, also at Cornell Cooperative Extension, the marine program. He has done a great deal of work on mollusks over the years, and in particular, the bay scallop. Some of his most recent work deals with the bay scallop restorations, where he's helped to create the world's largest spawning sanctuary right here in the Peconic Estuary. And that's helped to revitalize a previously lost resource and the East End economy. So, he's probably, like Brad said, the senior waterlogged person. So, but he has definitely done a lot of diving, and he still continues to do that at a pace that I'm always amazed by. So Steve, welcome and take it away.
Wow, well, thank you for such a wonderful introduction. Yeah, I've been very fortunate to work at Cornell as my day job the last 3 years. Prior to that, I was taught at LIU for many, many years. But I've been working on bay scallops for a very long time, and was fortunate enough to get involved with restoration efforts very early on when I came to Long Island. So in 1987, actually, I started working with Chris Smith at Cornell, and had the great opportunity to also work with Bayman, who I continue to work with and have learned so much from over the years. So I know you've seen this picture already, but I wanted to just say a couple of things about scallops and what the situation is with them right now. So as you've heard from Steve and Brad, there's not much eelgrass left in the system. Eelgrass is historically regarded as the most important habitat for bay scallops, but many areas of the Peconics have not had eelgrass for many decades. So the picture you see here is kind of actually very good habitat for scallops. The green stuff in the background is a seaweed or macroalga called codium, which actually is an introduced species in the 1950s. And the shell is Crepidula fornicata. It's a snail that forms stacks, and this actually turns out to be a very good habitat for scallops. So I've not been involved with eelgrass restoration whatsoever, but our group has been looking at habitats for bay scallops besides eelgrass. And Brad has been a huge partner in our work with these ecological studies as well as the restoration. Next slide, please. So back in the mid-1980s, you may remember that we had massive brown tide events in the Peconics that wiped out our scallop populations. And there was a series of years of restoration that were conducted at that time, and it did help to help scallop populations recover. But in 1995, we had the worst brown tide of all in the Peconics. Fortunately, knock on wood, it was the last one that we've experienced here. But for the next 12 years, when we were not doing any restoration, the scallop populations basically stayed at a flat line, and the harvest levels were only 1% of historical levels. So beginning in 2006, we were very fortunate to get bold and substantial funding from Suffolk County, and I see Al Krupski's on here, and I want to personally thank him for all his efforts on our behalf in the restoration work that we've been doing at Cornell. And so we started doing restoration work in 2006, and things actually went very well. We saw a marked increase in larval recruitment as well as population densities. And then the plot you see here is of the commercial fishery landings. This is pounds, thousands of pounds of meats. And after restoration, soon after restoration, these harvest levels increased dramatically. When we got up to 2017 and 18, These were the highest levels that had been seen, harvest levels, since 1994. And, you know, everything was bumping along really, really well. And then that all changed in 2019. Next slide, please. We'll get into this more later about this mass die-off of scallops, but I just kind of want to introduce that here. In 2019, we saw about a 95% die-off of adult scallops, and the fishery also declined at approximately the same level. Last year, 2020, we think the overall mortality was closer to 99%. And I haven't yet seen official landings for last year from the DEC, but it was very bad. And so this has had a huge economic impact on the bayment. You know, the benefits from the restoration work to the bayment and local economy were substantial, but you know, we're now in a situation where the resource is in peril, and we'll discuss this further later on. But yeah, that's all I wanted to say for right now. Thank you.
Okay, great. Thanks, Steve, for all that information and background. So we're going to move on to the next section, which is the poll that Elizabeth had mentioned and Lauren had mentioned before. So I'm going to hand it over to Lauren. This is important information that helps the PEP office reach their management and outreach goals too. So go ahead, Lauren.
Thank you, Matt. So right, as we mentioned, we'll launch our first poll for today. I'm going to distribute the first question. You should see that now. The first question is, what is one thing you value most about coastal wetlands? So this is a single choice answer here. So I'll give you a few moments for people to respond. Okay, looks like we're slowing up on some votes. All right, I'm gonna stop the poll, share the results. Wow, so most people chose the one thing they value most about coastal wetlands is the critical habitat they provide for juvenile fish, shellfish, birds, and other wildlife. Second is their ability to filter pollutants and help keep our waters clean. And third is the protection they provide from storms. And then, of course, wetlands really do provide many benefits, and other people recognize that as well. So this is great. So thank you for participating in that. All right, the next question is, what was your knowledge of living shorelines before today, and have you considered installing one on your property? This is a single choice answer question. So I'll give you a few moments to read through those. Okay, it looks like we're slowing up on votes. All right, I will stop the poll there, share results. Wow, another top favorite here. I had some knowledge of living shorelines, but do not live on the estuary shoreline was the most voted on. Second is I would consider installing a living shoreline on my property, which is great to hear. And then the others, I had some knowledge and in the process of installing one, which is cool too. So this is great information for us. Thank you. Stop those results. We have two more questions. The third question is, what do you think is the greatest threat to seagrass habitat in the Peconic Estuary? Okay, it looks like we're slowing up on votes again here. All right, I'm going to end the poll. Sharing results, the favorited choice is nutrient inputs and poor water quality as the greatest threat to seagrass habitat. Second is climate change. Third is hardened shorelines. And fourth is boating and fishing practices. Thank you for participating in that question. And our last one for this segment is, what do you think is the greatest threat to the bay scallop? Okay. All right, looks like votes are stopping. I will stop the poll there. And sharing the results. So the greatest threat to the bay scallop, a lot of people think, is climate change. Second is loss of seagrass habitat. Third is disease. And fourth is predators. So very nice that we had a lot of participation in that poll. So thank you very much. I'm going to stop those results, and I'm going to pass it back to our moderator, Matt, to now begin the panelist discussion.
Okay, great. Kind of fun watching those polls in real time. Sort of like
Yes.
watching horse racing or something. You're gonna put some
Yes.
bets down on them. So I think yeah, it's quite interesting to see some of the results too. Actually, I'm encouraged, and that there's such an awareness on so many of these problems. So maybe we can apply that in our panelist questions as well. But we've got a series of questions that have been prepared by the PEP program office that really touch on the previously mentioned management actions for the panelists. So I'm going to launch into these questions, and the first one is open to all of the panelists. So yesterday, the PEP had a great discussion on how to address climate change. Again, today, while our focus is on habitats and wildlife, restoring our coastal and nearshore habitats is going to be a very important piece in mitigating climate change. So I would like to start out by hearing from our panelists on their views on the importance of protecting and restoring our wetlands, the shorelines, eelgrass, and shellfish populations, not only for species diversity, but also for climate resiliency. So we're going to kind of spin this around a little bit from yesterday. So whoever would like to start, maybe I could start with Alexa on this if you're interested.
Sure. Thanks, Matt.
Sure.
All right, so protection of these coastal habitats has always been an important part of our mission at the DEC. Ecosystems are complex. We know that adding stress to an impaired habitat can lead to a cascade of increasingly poor outcomes and unforeseen consequences. But on the other hand, you can also see that thriving ecosystems provide benefits beyond their own immediate footprint. So salt marshes are a great example of this. Marshes act as storm buffers, protecting coastal areas and inland developments from flooding and erosion. When you have storm waves battering the coast, the dense vegetation within a marsh can dissipate some of that wave energy, and the sediment layer in the marsh can absorb floodwaters and from the storm surge and then release them slowly, buffering the rate of inundation to adjacent homes and businesses. So the protection of coastal habitats such as salt marshes is a key priority of New York State's coastal resiliency strategy. And in fact, the DEC and the Department of State have just released a guidance on this very topic. Lauren, if you wouldn't mind bringing up slide 1, there's a link here that will take you to the document that is a very comprehensive look into the variety of natural and nature-based features that can be used to increase resiliency along our coastlines. It's this one here, using natural measures to reduce risk of flooding. Yep. So yeah, I mean, again, we consider them very important for many reasons. Thanks.
Well, that's great. To follow up on the wetland question, the aspects of that. I found it interesting in the poll that people viewed wetlands as important habitat for wildlife, basically, as their priority, which is very interesting. Because after Hurricane Sandy, I was expecting it to be the opposite, that if they would have heard a lot of news about perhaps the value of wetlands for coping with climate change and coastal resiliency. So I know it came in second, and I think that's very important, but maybe Nicole, you can chime in a little bit on this and sort of give me your take on it and what you think might be happening here.
Sure. Well, I'm very happy to see that. I mean, any of those choices were a correct answer, right? Yeah. So because they do so much for us, and Alexa, I really like the way you say they provide benefits beyond their footprint. In terms of what restoring these habitats contribute to our climate resilience, I'd like to make a list of 3. They sequester carbon to mitigate future climate change. They attenuate wave energy to reduce the risk of floods. And if we give them what they need, they're self-sustaining into the future. And now you can't say any of that about a bulkhead or a seawall. So
this is true.
We're at a critical point, in the future of our planet. And Lauren, if you'd pull up slide 4. In order to meet the ambitious goals of reduced greenhouse gas emissions, we need to utilize our natural habitats that sequester carbon. In order to reach net zero greenhouse gas emissions by mid-century, to keep global temperature increases under 2 degrees C or 3.6 degrees Fahrenheit, we really need to make use of all of the carbon sequestration and fossil fuel reduction opportunities that we have available. New science by some TNC colleagues and partners show that natural climate solutions based on conservation, restoration, management of forests, grasslands, and wetlands can deliver more than 1/3 of the emissions reductions needed by 2030, and all while also providing clean water, clean air, and habitat for wildlife. So I bring this up to make the point that nature-based solutions like habitat restoration can provide a meaningful component towards our climate resilience goals, provided they're deployed in concert, of course, with transition to renewable energy, clean transportation, et cetera.
That's terrific. Yeah, I agree. What's interesting too, Nicole, is to me, you see a lot of these, it's sort of a green infrastructure approach to what we're doing here. It's a shift, it's a mindset shift, it's a management shift. Even in the urban environments, you see a lot of greening of even trying to make bulkheads there's no way you're going to restore the shoreline over there in these channelized areas probably, but they try to green the infrastructure even with, some other adaptive methods and technologies to put some wetlands and, planter holders. And so I think this is definitely the future. And, the more that people are aware of this, I think the better. Trying to make that link with eelgrass might be a little bit more tricky in people's minds. They might not see how coastal resiliency, maybe how important they would be, but maybe Steve Schott and Brad Peterson can help a little bit get into some of that. And we'll start maybe with you, Steve, on this, how we can view eelgrass as a mitigative tool for the climate resiliency.
Seagrasses are one of those because they're out of sight, they're kind of out of mind. You're talking these plants, and many people on Long Island aren't even aware that these ecosystems exist under our waters. That just leads to the fact that they're either not understood by the public or misunderstood in many cases. I know certain estuaries on Long Island view eelgrass as a nuisance. We should be happy that we still have that nuisance, and in the future, our future generations may be really appreciative if they could have had that if we don't turn a corner. But eelgrass, we're talking about carbon sequestration influencing our climate change. Seagrass meadows have been found to be some of the highest rates of sequestration of carbon of any other ecosystem on Earth. Our issue with seagrasses is that globally our seagrass meadows and populations are in decline. So you're taking these meadows that not only provide habitat value and other ecosystem value, but are potentially a great tool for us to control our climate issues at this point, and they're shrinking and we're losing them. So a really valuable tool is being lost. For my work with and addressing the question with protecting and restoring, the other thing is, because eelgrass is below the water, we don't think of it as an actual protective mechanism, but eelgrass meadows, if you think about it, almost act like snow fences. They slow water movement down, including wave action. So these storm surges, like during Superstorm Sandy, or just even our normal winter nor'easters, as those waves roll into the shore and they go over an eelgrass meadow, those meadows really do a great job at reducing the energy that will be actually impacting our shorelines, and in which case they actually result in decline in erosion, or at least a reduction.
Right. So Steve, that's really interesting. It's sort of the out of sight, out of mind kind of catch over here with eelgrass, but you also mentioned that they're viewed as a nuisance, and I just was wondering if you could describe to people why that might be.
So not so much in the Peconics, but on the South Shore estuaries, the North Shore of the Great South Bay has a lot of canals. They don't have a lot of eelgrass on the North Shore. The eelgrass would be along Fire Island National Seashore and some areas in the middle of the estuary. Eelgrass sheds its leaves every 10 days to 2 weeks in the summertime to get rid of fouling organisms, natural process. And when you have a couple hundred or 1,000 acres of eelgrass shedding its leaves at that point, and then you get those nice southerly winds that are blowing all that eelgrass up into the canals and into the marinas on the north side of the Great South Bay, people aren't really thrilled because it clogs their engines. There used to be so much eelgrass naturally in Great South Bay that they actually created mechanical devices, either props that are supposed to be called the weedless props, so that when the boat's running over the eelgrass meadows wouldn't get fouled, or strainers that were actually put over for intakes to prevent the eelgrass from clogging engine intakes. So in the Great South Bay, and those were developed in the Great South Bay in response to the eelgrass. Now that was a bygone era that doesn't exist at this point. So, but yes.
That's very interesting. So you would see it as a nuisance, but it's incredibly important for so many other reasons. And, Brad, maybe you want to expand on that a little bit. Maybe there's some more about carbon sequestration that you can talk about.
Yes, I did want to make note of the Blue Point beer, the prop stopper, which basically was a result of the frustration with eelgrass there. Anyway, two things though that I did want to point out about eelgrass and climate change or erosion control. So the one thing that Steve mentioned about erosion and wave attenuation has been really well recognized. But one thing that people don't normally think about is that the leaves of seagrass are plastic, right? They're fluid, they move. And when there's lots and lots of flow, they lay down flat and actually create a cap on the sediment surface. And so in high densities, they can really reduce the loss of sediment where they're present. So that's something that people don't normally think about. Nope. And the other thing that I was going to raise is, people have heard the term ocean acidification, the increase in CO2 in our water. Seagrass, just like any other plant, will use that CO2 for photosynthesis. And what's amazing is we've made these water intake probes that we could walk across the landscape and pump water up from 5 centimeters up from the surface. And I could be just walking across and the person in the boat can tell me, oh, you're in grass. You've moved into sand, because they can just measure how rapidly it drops down that PCO2 or increases the pH. And the reason that I bring this up is that Steve made a very true point that said that, seagrass is not the dominant habitat that's necessary for scallops in the Peconic. But because they create this increase in aragonite saturation level within their canopies, those shellfish that are recruiting to seagrass habitats are basically in a refugia from ocean acidification. And although most people think about ocean acidification in the ocean, we have locally this issue of coastal acidification, where it's all of this productivity that's been stimulated by nutrients in the water column, that when it falls down and increases the organic matter in the sediment, that then on a daily cycles much greater than any kind of acidification that's seen in the open ocean. So we're experiencing things that they're projecting in 100 years in the open ocean right now in Peconic Bay. And so I think that that's another role that seagrass plays in combating this idea of climate change.
Yeah, that's fascinating. And that idea of the refugia is also very interesting as well. I think you're seeing that more and more. You saw it sort of with the Long Island Sound and the lobsters, then the die-off, and how they find these little deep pockets and they're just colder water refugia, you know. And I think eelgrass is experiencing a similar type of event in the Peconics over time. So, you know, you want to bolster these if you can, get all that great carbon sequestration, get all the benefits of the habitat, like you're saying, for coastal resiliency. And it's a natural fit with the shellfish and the organisms that occupy that space. So with that, Steve Tettleback, I'm wondering if you have anything that you could think of for coastal resiliency with mollusks, shellfish, that might be applicable here.
Actually, I wanted to, before I talked about scallops, I did want to say a couple more things about just the habitats, you know, the wetlands, the eelgrass and shorelines and so forth. You know, we're losing all of these critical habitats and continue to do so. And especially now with the climate crisis, this is accelerating. So these are incredibly valuable habitats for wildlife. And when you lose these habitats, the biodiversity may be at risk of declining. Biodiversity is shown time and time again, regardless of what ecosystem on Earth you're talking about, whether it's in the water, freshwater, marine, on land, biodiversity is essential to the proper functioning of these ecosystems. So when you start to lose biodiversity, you know, we generally think of the species that mean the most to us, you know, scallops and fish that use eelgrass and salt marshes as habitat, but all the critters that live there are essential to the proper functioning of these ecosystems. So when you start to pull out straws, like in the game of Jenga, you don't know when that system is going to collapse. So maintaining and restoring these habitats is incredibly important. It's been shown that, I think the Cornell group has said this especially well, is that it's easier to protect existing habitat than it is to restore it. And so, and probably has more value in and of itself. So that's incredibly important. In terms of shellfish populations, you know, it's not just the economic benefits that we reap from them. You know, shellfish are filter feeders, and so they are helping to maintain water quality. And when you remove those populations, the water quality can go south in a hurry. I mean, all we have to do is look to Great South Bay, where the hard clam populations in the 70s supported one of the largest shell fisheries in the world, and those populations declined dramatically by the mid 80s, and the water quality has been very poor since that time. So when you have healthy shellfish populations, that makes for better water quality in addition.
That's terrific points. I mean, covered so much ground on this one question. It's amazing. So many important topics relevant to the estuary program. And I think building on that last little bit of information you provided on it's easier to protect these habitats than to restore them. It leads us to the next question. The Peconic Estuary Habitat Restoration Plan contains a list of priority habitat restoration sites, and PEP has been working diligently with their partners to prioritize wetland and shoreline restoration projects, and also try to move the top priority projects forward. So I think a lot of you have been involved with this, but in particular, Alexa, Nicole, and Steve Schott, you've all been very involved in these types of efforts. So I'm just wondering, I'm going to target it to you three initially, and if anybody else wants to chime in, please do so. Can you discuss some of the threats our wetlands and shorelines face and the challenges to restoring and protecting these habitats that we currently see? Anybody want to start?
Sure,
Okay.
I can.
Thanks, Nicole.
I'd say one of the challenges is that we've got this balance between urgency and caution. You know, our salt marshes don't have a lot of elevation to spare, and changes are happening very quickly, sometimes with even within a single growing season. But at the same time, we have to keep in mind that a lot of the restoration that we find ourselves needing to do now is because of ill-advised practices in the past, or at least activities that weren't climate resilient, such as old agricultural embankments, or the effects of the linear or grid mosquito ditches, or ditch plugs put in. And so we really need to be, we need to sort of act now, but we need to be very careful and monitor and learn and communicate from what we learn when we do restore these systems.
Okay. So just so people understand a little bit better, when you talk about the elevation, what's the struggle there? What's happening? And maybe you could expand on that a little bit so people get a better sense of what they're dealing with and the challenges they face exactly.
Sure. So salt marshes are an intertidal habitat. They thrive just at that right balance where the tide comes in, but then the tide goes out. So they may not look like they're moving, but when they're healthy, they're actually growing vertically to keep pace with sea level rise as sea level goes up. But it's sort of a pair of paradoxes, because they need the tide to come in, but too much flooding and they'll drown or sink. And they need the tide to go out because they need to oxygenate their roots in order to take up nutrients and photosynthesize and grow. And so if we drain them too much, the sediment can become oxidized and settle. And so we really need to make sure that these systems are healthy in that balance of where they need to be so that they can grow and keep pace with sea level rise, both in place, but then also migrating landward.
I saw some staggering numbers yesterday about the climate change session with sea level rise, and it's alarming to say the least, in my opinion. Do you think there's a chance that they're going to be able to keep up with that rate of sea level rise in this current situation?
I think that really a big part of them keeping up is being able to migrate landward. We've got marsh migration projections for those different sea level rise scenarios. We have in our extra slide deck some slides. I don't know if you want to share them now. So this is just a quick picture of the types of the way we measure how salt marshes are growing in elevation and the different components of their elevation growth on the surface, within the actively growing roots and rhizome zones, and then below subsurface. And the next slide, Lauren. This is a snapshot of the rates of elevation change at our set of elevation stations from Long Island, not only Peconics here. The dark line represents the long-term sea level rise rate as measured at NOAA's tide gauge at Montauk. So just over 3 millimeters a year over the last 70 years. And what you can see is a lot of our marsh systems are more or less keeping pace with that historic trend, but we know that sea level rise is not happening in a steady linear way. And we also know that it's accelerating. So what my colleague Adam Stark and I need to do over the next few months is dive into this really rich long-term data set that we have at our stations and the stations being monitored by our partners like DEC and New York City Parks, and figure out, the big question here isn't our marshes now keeping pace with the historic rates of sea level rise, but how are they going to be able to respond to the shorter, much more rapid increases in sea level rise? And so the importance of migrating landward is shown in the next few slides. So Lauren, so this is, I have to look closer to see the year here. From the 2050s, you can see the greatest, this is an example from Accabonac Harbor in Peconic Estuary. The greatest chance of salt marsh existing in the 2050s is in that dark green color, is mostly where it is today, but a lot of it is over that black line that identifies the boundary between what's salt marsh today and what's adjacent property. And if you move to the next slide, Lauren, this shows it'll show the 2080s scenario, where you can see there's some lighter area showing up at the edge of the salt marsh because it's got reduced chance of existing back in into the 2080s under the sea level rise projections that we anticipate. And more of that, more certain, that dark green 80 to 100% likelihood of being salt marsh is moving more landward from today's salt marsh landward edge. And the final slide in the series is from 2100. You can see most of what we know as salt marsh today is got a diminished likelihood of being salt marsh in 2100. The greatest chance that we have for salt marsh, and this is true across the Peconics, but for this example here in Accabonac Harbor, you see is right at that upland edge of what's salt marsh now and landward of our land salt marsh boundary.
Yeah, wow, that's amazing. Lot to think about, that's for sure. Wow. Well, thanks for all that overview, Nicole. It's just really great. Nice modeling work too. I think I just want to move to Alexa and maybe ask how the state is working to address some of these challenges that we're talking about here. Is there some mitigative strategies, some plans, some policies that people can learn about to help with these things?
Yes, we are working on this. This is obviously one of our biggest concerns. So, statewide, we have some initiatives in place to start to consider some of the greater implications. In 2019, New York State passed the Climate Leadership and Community Protection Act. Now, the majority of this bill discusses things like our very ambitious greenhouse gas reduction targets and clean energy standards. But in addition to that, this legislation now requires state agencies to consider future climate risks when evaluating permit applications. And it explicitly recognizes the importance of protecting and restoring natural features. And again, I can point you to that guidance document from before, but the feeling that I have been getting from my contacts in Albany and just sort of in general is that we are beginning as a state to really understand these are important. We really have to protect these marshes that we have because sea level rise is really happening, and it's happening very fast. So in addition to that, we have the state sea level rise projections, which gives you a very looks at different regions of the state and where we're projecting sea level rise to be under different timescales and under low, medium, and high sea level rise projections. So that's just a little reference point you can use to kind of think, well, maybe in 30 years, where can I expect this shoreline to be? That information is built into a lot of the mapping that we're getting that's coming out of this to kind of really look into the future and see what we can expect and where should we target our restoration efforts. So again, we use that information to try and restore parcels that are doing okay, but are at high risk, and protect the ones that are doing well. We have several sites on the South Shore that are, either in process or we're in hopes of getting restored very quickly or very soon anyway. And, we're always looking for parcels, potential acquisition sites where we can buy up land and in order to give these marshes, migration pathways and, just prevent future development by, acquiring these in the state coffers. So I feel like we are taking an active role as we can and always hoping to do more on that front.
That's great. Thanks, Alexa. I think certainly sea level rise is a dramatic issue that we're going to all have to contend with. No easy solutions at the moment, but hopefully we can have ways to mitigate and offset. I think, when you talked about the open space being important, that allows the marshes to migrate. I think that's a very important tool. And Legislator Krupski, I think, talked about that in one of the sessions, that, that's certainly really important, probably long term, that you can have that kind of land available, not only for marsh migration, but because of nutrients in those systems. So we have, we kind of have a very fragmented habitat, both terrestrially and also in a submerged setting. So, kind of what we want to do is talk about solutions as well, how to kind of connect these things. And I think maybe Nicole and Steve, you can both talk a little bit about some of the solutions that the Nature Conservancy and Cornell are engaged in, or things that we should be thinking about in the future in the Peconics. Nicole?
Sure. Steve, do you want to go first?
Sure, I could do that.
Okay, Steve.
One of the things that Cornell has recognized is that there's a continuum on our shoreline from the upland edge down into the subtidal regions where we have our seagrass meadows. So in that, with that thought in mind, our approach has been to develop an outreach education and our restoration plan under the term of marine meadows. So we're looking at these habitats as all vital and in this continuum. And where we can, we try to, work with offshore in the eelgrass meadows to try to provide that kind of buffering, and then move into the intertidal zone, and then try to protect our upland edges. Now, one of the just to hit on one of the challenges, and again, it goes back to Legislator Krupski yesterday, and with the sea level rise discussion, hardened shorelines and bulkheads are really an issue for the Peconics. And from 2000 to 2014, or more recently, I don't remember the date, Elizabeth could probably update us, but we've seen a marked increase in hardened shorelines in the Peconics. And even as a nation, I think the last stat that I read from NOAA was they're estimating a third of the shorelines in the United States by 2100 will be hardened and non-natural, non-living, and that really is a real problem, because we're not only losing, habitat and ecosystem function, but Legislator Krupski mentioned these hardened shorelines don't hold up against the storm forces that we're expecting to see with continued climate change. So I really think that we need to start looking at, and people are starting to embrace this. We see this with Cornell. We really do interact with the community and homeowners. There's a lot more interest now that New York State has released their living shoreline guidance for homeowners to really consider this. Not only are bulkheading or hardened shorelines costly to install and replace, but in many cases, they, again, with the way sea levels rising and things are, and environments changing, they're just not effective. And homeowners, we've been seeing in the past few winters with some of our coastal storms, homeowners we're getting these high tides that are overtopping people's bulkheads, and actually the bulkheads are acting as dams and holding the water back on people's properties and causing more flood damage. So we're starting to see homeowners saying, well, I'd rather have the water come all the way up onto my property, but once the storm's over, recede than the issues I'm having now. Also, it's an aesthetic issue. So really, I think one of the biggest things is, and again, this is kind of Cornell's basic mission, is to educate the public and give them options. People are saying they'd love to know, what are people doing? What are our local governments doing for climate change? That was one of the poll questions yesterday. And people want to know what can the local governments do, but what can they do as well? So I think we need to increase our education and show that these are viable. These living shorelines or other options are viable, and going to be a really key tool for dealing with issues along our shorelines in the future.
Great. Nicole?
Sure. Thanks, Steve. I think, in addition to outreach among the public and engagement among the public, I think one of our solutions is better engagement and partnerships among restoration practitioners as well. And this is a really big role that PEP plays. I mean, we don't have time to practice random acts of restoration, and nature doesn't have the luxury of time to wait for us to proceed that way either. We need to be strategic. And so one partner organization, Audubon, has committed to hosting a workshop to review and share knowledge about different regional data sets, like that vegetated, unvegetated data set that Alexa mentioned that DEC paid for USGS to develop, and other tools, so that we can learn what's out there and proceed in a strategic way. Another example was the Regional Salt Marsh Restoration Learning Exchange that was supported by Suffolk County as part of their post-Sandy NIFWIF grant that was assembled and led by the Nature Conservancy, where restoration practitioners from across the whole sandy impact region of the Northeast got together over a couple years to share lessons learned and current thinking in restoration science to improve the success and efficiency of restoration projects, both in Suffolk County on the South Shore, but also across the region. Other learning exchanges that PEP has tapped into is a new venture from Fish and Wildlife that they are calling their SMART teams. And SMART's an acronym for Salt Marsh Adaptation Resiliency Teams. And it's a collaborative approach for salt marsh researchers, restoration practitioners, and managers to receive guidance on current thinking in restoration science. PEP has reached out to the Fish and Wildlife SMART teams to make sure that hydrological restoration in Accabonac Harbor, for example, is well thought out. So I think that that's some of our solutions is being engaged and learning from each other and communicating lessons learned, even when those lessons come from what we think of as failures, because that can launch us forward.
Okay, that's great, Nicole. Thank you, and Steve. So we have a lot, again, to do on the ground with communication and outreach and bringing the right tools to the table for the local governments and to put into action. So that's something that the Peconic Estuary Program partnership does a really good job of. And so I agree with you. That's definitely where we need to head to. So I'm going to move along to the next question, which is dealing with seagrass. Seagrass habitat in the Peconic Estuary has definitely experienced a dramatic decline, as much as 90% since the 1930s. And so far, seagrass restorations have had limited success. So from that, what are some of the challenges to restoring seagrass, and how do we manage for this? So I'll start off with Brad on this, if that's okay. Brad, you want to pick up?
Well, on the discussion that was just going on regarding the hardened shorelines, a recent modeling activity for seagrass in the Peconics demonstrated that distance and wind angle played a role in where limiting restoration possibilities where the current grass, using the current grass as an example.
Mm-hmm.
So the thing that I think is the elephant in the room for eelgrass in the Peconic as far as climate change is temperature. And so I was hoping that I could get the slide number. Thank you so much for that.
Mm-hmm.
So what you're looking at right now is a line that limits where there is grass in the Peconics. And so there is no grass further west of where this line was. There was in 2000, but by 2014, there wasn't. Could you go to the next slide, please? And this corresponds pretty clearly to the numbers of hours over a threshold. So when the temperature gets above 25 degrees Celsius, the plant just can't get enough carbon to sustain itself in those warm temperatures. And so there's this very clear association of where we're finding grass and temperature. Although there is one particular weird oddball that Steve may want to address because of the time that he spent there right now before talking any more about temperature.
Yeah, so one meadow in the Peconics that is not on this map is down in Bullhead Bay, Sabonic Harbor area. This is definitely an oddball. Water temperature in Bullhead Bay can reach into the mid 80s in the summertime, yet which should be lethal temperatures for eelgrass based on everything we know about eelgrass. However, we've got a meadow that has not only survived where everything else in the Western Estuary has not, but it continues to flourish. And it saw a decline back in 2010. I think the meadow had shrunk to about 5 acres. And since 2010, we've actually seen a resurgence and it's back up to about 60 acres. So Bullhead Bay, Brad and I have had many conversations about Bullhead Bay, and it definitely is one of those anomalies, but it's a good anomaly because I think it holds potential answers to how we may address temperature stress, or at least in terms of restoration, which is, you know, what Cornell really focuses on. How do we pick better locations or the best locations for future restoration? So that's all I'll have to say. If people have other questions about Bullhead Bay, we can deal with them.
But
Brad.
Steve, can you give us insight as to why there's grass there at all?
Oh, I'm sorry. Thank you. So the reason we think that there's eelgrass in Bullhead Bay is that there is definitely a pronounced groundwater, submarine groundwater discharge. So you're seeing the aquifer is actually releasing into the subtidal coastal waters. And what that's doing is creating a cool layer around the meristematic region and the rhizome area for the plants. Now that helps reduce that problem that the plants have with acquiring and holding on to carbon during high temperatures. So this is something that Brad and I and his students have had a lot of conversations about, and we're now starting to include USGS into this discussion because they have some tools that could be very useful for us in the future. So thank you for that segue.
So could you go to the next slide for me, please, Lauren? Now, what you're looking at right now are temperature loggers recording temperatures in the far west, the mid, and then the east where there is grass in the Peconics. And what I want to point out is that you'll see that these numbers these are hours over this exceedance. And so in the west and the east, they're all much warmer than what west and the mid are all so much warmer than we see in the east. And if you look at the east, the difference in color are the shallow versus deep. And so what we see is the shallows are warming up first and are staying warmer than the deeper water, which is giving us some insight. And if you could just go to the next slide quickly. So I think that what we're seeing is where there is grass in the Peconics, we have kind of them squeezed between the lower limit, which is a function of their light limitation, and this upper limit in the shallows driven by temperature where they are. So these are the issues that we're wrestling with, and I want to talk kind of what Nicole was mentioning for the salt marshes just briefly, in the sense of saying that the rate of loss or the rate of change is increasing, right? And so and because of that, I think that practitioners and academics and NGOs doing the work have to become very creative in what might be some potential ways to combat this. Steve mentioned using perhaps models developed by the USGS to find some cold water refugia as sites to look at, and I think that we should pursue those. Other issues are perhaps looking for functional genotypes that can exist in warmer waters, and perhaps using more of a targeted strategy for restoration to get some of these particular genotypes that would succeed in the habitats that we have now.
Wow. Well, that's a really cool and interesting model. Tough story though, you're getting squeezed, like you said, into these interesting little zones, and it's like a refugia. So if we use a different type of variety that's a little more temperature tolerant, would that encourage us to try to restore and go out there and plant those? Is that sort of what one of the working models might be?
So usually when we think of changing temperature, we think latitudinally, right? Virginia, whatever. But even within Long Island, we have areas that are warmer and colder. And so I think that step number one would be for us to see whether or not we could find some functional genotypes that would be able to survive even within the groups, the grass that we have here. And I know that this is not unique to Long Island, and that there are other groups and other places along the East Coast that are pursuing some of these questions.
Yeah, that's a lot. That's great. Thanks for that, Brad and Steve. All right, so we're going to move along now to the iconic bay scallop. I would say that, this species that was mentioned by Steve was decimated by brown tide and literally gave rise to the Peconic Estuary program in the 1980s. It's, you know, once again, it's been experiencing a really tough couple of years. So, you know, maybe Steve Tettleback, you can talk to us about this, where you can talk about the efforts that are being undertaken to understand the threats to the species and, you know, expand on that a little bit.
Sure. Yeah, you know, in 2019, when we first started to hear rumors about this, you know, we just didn't want to believe that this was going on. But when we started doing our surveys, you know, it became abundantly clear. So we've been doing, as part of the scallop restoration efforts, we've been doing population surveys of scallop populations since 2005. So back in the early days, Brad and my students and I would go out in March and start our spring surveys. And as we've gotten older, we kind of are doing this more in May and June now, you know, but that's okay. We still get good data. So we've done these surveys in the spring and the fall for 16 years now. So we feel we have a pretty good idea of what's going on with populations. And I should say that we have about 20 sites that we routinely visit over time. Actually, during that time, we've also seen the disappearance of eelgrass, not coincidentally. So in 2019, the die-off just felt different. I mean, we've been doing this a long time, and it just felt like something different was going on. It was not localized to one area of the Peconics. It was not just in the western end. It was all throughout the bays. And it also just seemed to have affected adult bay scallops and not the juveniles. So this was kind of strange. So if I could have the first slide, it's number 16, please. So we started thinking right away about, okay, what's the cause of this? So the hypothesis that we've been working on, and I'm going to actually talk about some of the data that we've collected, is that again, the mortality is just of the adults. So the adults are capable of reproduction, the juveniles are not. So we think that the process of spawning, which is physiologically stressful, is part of this story. So we think that the stress of the spawning, in conjunction with higher water temperatures, part of climate change, lower dissolved oxygen levels, part of climate change, and a newly discovered disease discovered by Dr. Bassam Alam at Stony Brook in his lab, that combination seems to be a plausible explanation for why this mortality occurred. I'll talk next about these Counos Rays. This is kind of the wild card in all of this. This is a southern species primarily, but it has been showing up in big numbers in our waters in the last couple of years. So all of these things really, we believe, are being driven by climate change, okay? Now you might say, well, what about the disease? The disease, we don't really have a baseline of information on this, but anecdotal information from discussions with people in Rhode Island and some published literature from the 1980s in Massachusetts suggests that this disease may actually have been there all along, and that now, because of these additional environmental stressors, the disease is having more of an impact on the scallop. So this is our working hypothesis here. So one of the things that we've looked at is what is different in 2019 and 20 versus 2018, for example, when there was a huge scallop harvest. And one of the things we found was that the alignment of spawning periods in 2019 and 20 seems to have occurred when the water temperatures were at very high levels. So we're talking about levels of like, 82 degrees and 85 degrees, somewhere around there, depending upon where you are in the bay. So these are temperatures that are already pushing the red line for scallop survival. But when you throw on top of that the disease and then also the stress of spawning, we think that this may be driving part of the mortality at least. In 2018, when you look at the spawning periods, they don't align with the highest water temperatures. They're actually more moderate temperatures. So we don't think that there was, any significant amount of mortality that was resulting during the process of spawning. In 2020, we did additional surveys in the summer between our spring and fall surveys, and we saw that by the end of July, there was already over 50% mortality of adult scallops. And this was before Counos Rays are thought to have showed up. It's before there was a bloom of rust tide. And so we think that that is really strong evidence that supports the hypothesis that it was the water temperature in combination with disease and probably lower dissolved oxygen. That same year, last year, by the end of August, there was almost 100% mortality of scallops already. So, you know, this happened well before the harvest season, which starts in November. Interestingly, the scallops did spawn successfully, and there has been really good recruitment of scallops in the last couple of years, which is critically important because scallops generally don't live for more than a year and a half. So if you lose even just 1 year, 1 year of spawning, 1 year class, the population can very quickly go down to very low levels. Next slide, please. So Counos Rays, this is a species, like I said, is primarily southern in distribution. You know, occasionally it's been seen in Long Island over the years, but in the last 2 years, people have seen schools of these in the thousands and in the tens of thousands. And they're notorious for eating adult shellfish. In the lower left corner, you see what their buccal apparatus looks like. So they actually will crunch down adult shells of scallops, oysters, into little bits. And so, you know, are they important in this mortality? Well, in the scientific literature, it was shown in North Carolina that they wiped out scallop populations in some areas of North Carolina in the 90s. So it's suspicious, you know, that they're here and we saw this big die-off, okay? One of the things also that's odd in the last 2 years of our surveys is that many of the areas where we do our dive surveys, we don't see empty scallop shells, what we call cluckers. These are where the two shells are still together. You know, you can look at these cluckers and determine, okay, if there's no damage, you know, it's likely it was due to some environmental factor, all right? If it's due to a predator, like a crab, you'll see chips along the edge of the shells. But the fact that there were no cluckers in many areas was very odd. And we haven't really seen this much over the years. So again, getting to this idea that Counos Rays crunch down the shells into little bits was very suspicious. It's not a smoking gun, but it's suspicious. So we are interested in doing more work on looking at what these guys are actually doing. So let me just pull something up here. So this past year, we did a bunch of work investigating the progression of the disease. This was a project that Bassem Alam got funded for, and we participated in at Cornell. And so what we're trying to determine is, you know, how important is this disease in terms of causing mortalities. So if I could have the next slide, please. We did a series of laboratory experiments as well as field experiments. These are lab results from one of Bassem's PhD students, Madison Newell. And what it shows is that the survival of scallops was much lower at the highest water temperatures. So the red line here is 28 degrees Celsius, which equates to about 82 degrees Fahrenheit. That was considerably higher mortality than compared to 25 degrees C, 77 degrees Fahrenheit, or 22. So again, the 28-degree temperatures these are not what we typically would experience in the bays, but we've been seeing this more and more in the last few years. So it may be this kind of thing like Brad was talking about with the eelgrass, where it's the number of days above a threshold temperature, you know. So that's one of the things that we plan to investigate further. So Lauren, could I bother you to go back to slide 16, please? Yeah, so what we're planning to do this year, we've been very fortunate. I want to thank Alexa and Dawn McReynolds and Debbie Barnes and DEC for providing funding to look at this die-off in much more detail than we've been able to do up to this point. So Brad and Bossum and their labs and our group at Cornell are going to be looking at these factors here that are part of the hypothesis. So what we're going to be doing is we're going to look at about 7 to 10 sites throughout the Peconic Bays, and we're going to deploy continuous meters that will continuously record water temperature, dissolved oxygen, salinity, pH, food levels, because we want to see how this aligns with spawning and with mortality. We're going to do reproductive analyses every 2 weeks from May through October. And we're going to look at the progression of the disease. We're going to look at physiological condition of the scallops. We also plan to look at Counos Ray predation. One of Brad's students is going to do this as her master's thesis. And we're also going to try to get more information about, when do the rays show up? Where do they go? How much time do they spend here? And then ultimately, are they eating scallops? So we're hoping to get further information about, what we think is driving these mortalities. So what can we do about this? Well, first of all, in order to really efficiently and effectively address a problem, you have to know what the problem is. So we think we know that environmental factors are part of this. We don't yet know about Counos Rays. But what can we do about this? So if it is, in fact, these higher water temperatures and the disease and low DO, it's actually possible to selectively breed scallops for resistance to these environmental factors. This has been done very successfully with oysters to address disease, like in the Chesapeake Bay, for example. And I'm not talking about GMO scallops or Franken scallops here. We're talking about taking advantage of the variability, the natural variability in the genetics of these scallop populations. So the idea is to select scallops, take scallops that have survived these conditions, whether it's in the lab or in the field, use those as the parent stock to produce scallops that theoretically should have a higher resistance to these environmental factors. So I really think that's our best hope to try to address that. There's been some suggestions of crossbreeding our scallops with southern bay scallops, but I'm not quite ready to go there yet. It may end up that's the strategy to follow, but not yet. And then, like I say, we're going to try to figure out what we can, are Counos Rays important, and if so, then we'll start to think more about what we can maybe do with it.
All right. Well, thank you, Steve, for that incredible overview. Really tough situation again for scallops and natural resources, temperature, climate change. These are things that are sort of a little bit out of our hands in some ways, and it's going to take a much larger effort nationally and globally. So, along the lines of these challenges and, having to maybe turn to different types of genetics and, selective breeding to be more climate resilient as a organism, we kind of have to stay focused on that. I guess that's going to be the new approach to restoration and to management. So I guess what I want to do is I guess we're going to wrap up here. We're getting pretty close to the end of this session. We saw that there are many threats facing the habitats and wildlife in the Peconic Bays. But we have also discussed several ideas today of how to press forward with restoration efforts. So I just want to close by asking the panelists if they are optimistic about restoring habitats and wildlife in the Peconic Bay, and what is it that gives them hope. So whoever feels brave enough to start first, let me know. Okay, Nicole.
Sure.
Great.
I am optimistic. I mean, this situation is urgent. There's no doubt about that. But there are so many benefits to getting this done right. And there's wide recognition of the need to do so. And the desire to act now is really palpable. So we may all be coming at this from different perspectives because we are a diverse group of partners and stakeholders, but we're united behind this common goal to achieve a healthy and resilient Peconic. And PEP is a fantastic facilitator for this. So yes, for those reasons, I am optimistic.
That's great. Steve Schott, would you like to go?
Sure. With the support of PEP, again, from the aspect of the eelgrass monitoring, we've been able to do and identify a lot of key variables that will, now that we're pretty certain the temperature, as well as with Caitlin O'Toole's model that Brad discussed, we have these factors that we've identified. Finally the science is there to give us the direction we need to go in. So we spent a lot of time planting eelgrass when I first started Cornell in the wrong places, because eelgrass used to grow there. We need to find out where eelgrass is going to be able to grow and stay alive. And the funding that PEP's provided for all the research that's been done has definitely helped with that. And that gives me hope. The other is working with the community and seeing that more and more people are willing to get their hands dirty and put some sweat equity in volunteer efforts and workshops that we've hosted and other groups have hosted to really affect the change. And that does give me hope. And especially the younger generations, they really are enthusiastic, and they're really a lot smarter than my generation is and much more aware. So that does give me hope.
That's great. And that kind of follows up a little bit with, what Nicole was saying as well. So, all good points and really useful. I think hopefully the younger generations will step up as well and be even more motivated than we are. I'm going to keep continuing on who I see on my screen. And so Alexa, if you have some input on this.
Sure. So yeah, I would say that I'm absolutely optimistic. And I think in this line of work, you kind of have to be, because if you're not, then what are you even doing? So I think it's, it does give me hope to see a lot of the progress that we've made, just really changing people's minds. For example, 10 years ago, I felt like climate change was something that was much more abstract to most people that were kind of outside of the scientific community. But nowadays, part of that's because it's become so obvious. But now pretty much along the coastline, there's a much higher level of percentage of people that are accepting that, like, yes, this is happening. Yes, we need to do something about it. What can we do? And let's solve these problems together. And I think once you have people kind of much closer to united on an idea, then it's much the possibilities really open up. So I am optimistic about where we'll be and at least what kind of good things we might get done.
Okay, great. Thanks, Alexa. I see Brad on my screen now.
I'm optimistic, and I am optimistic for many reasons, but also, Steve mentioned it here. I work at a university. I'm surrounded by young people who are, they're excited, but they have open eyes. They're not, they realize the challenges that are ahead, and they are saying, I'm going to try to go down a path where I can address some of these issues. Specifically for eelgrass, eelgrass grows all around the planet in the Northern Hemisphere. It's a very plastic plant. And it's, when the situations are improved, the plant has a great capacity to grow. What we've seen is that human population along the shore has caused over enrichment of nutrients, which is a light stress, and caused a lot of loss in a lot of places. And we know that our temperature is warming, and that's another problem that we have for the Peconics. But yeah, I am optimistic. I'm optimistic because I think that people's are not neglecting the problem, they are facing the problem. And now we got to be creative. And that's where we're at right now.
Okay, great. Thanks, Brad. Steve Tettelback, would you like to say anything?
Yeah, make sure I unmuted. Yeah, I'd say cautiously optimistic. We've had good success with scalp restoration in the past. Nobody knew, what brown tides were when they first happened in 1985. And we didn't know if the restoration was going to have any success. And and it did. And then our most recent round of restoration was very successful. So, you know, we've certainly learned a lot about the process of doing restoration. And, you know, this is a different challenge, and it's a big challenge, of course. You know, we're dealing with climate change here. So, you know, we need to get our ducks in line. We need to better understand what exactly is going on, what's driving this, you know, and then adapt our strategies. But yeah, so, you know, there's a lot of good folks working on this, and you know, everybody gets on board with this. You know, the potential certainly is there to help turn things around.
Excellent. All right. Well, I think that concludes our panelist discussion. I'm going to kick it over to Lauren, who's going to do a post panel poll here for the audience to participate in. So go ahead, Lauren, take it away.
Thanks, Matt. So we're getting a little close on time here, so I'm going to do this pretty quickly. So the first question, there's 3 questions. Our first question is, which CCMP to our management plan, healthy ecosystem issues or actions do you think PEP should prioritize? And you can choose 2 for your answer for this. And there's a lot of choices.
Yeah,
You might have to scroll.
Yeah, scroll down.
So I'll give a few moments for this just because there's a lot to read through.
I feel like you need to do the racehorse thing. And climate change is closing in on protect restore eelgrass beds.
It is what it is.
And
All
by a
right.
nose. Whoa, still coming in.
Yeah. All right, it looks like we're slowing up on some votes. Most people have voted, but they're still coming in, so I don't want to cut anybody off. All right, it stopped there for a little while, so I'll stop and I will share results. And we have a tie for climate change impacts that harm habitats and wildlife, and protect critical natural resource areas and high priority land. So these, the people in the audience today feel that this is something we should prioritize. And a second is increasing our understanding of the species and what strategies we should do for key species to protect and restore them. And another second is restore wetland habitat. But of course, everyone picked at least one thing on this list because they're all very important and we should all continue to focus on these things. All right, second question. What is the easiest way for you to participate in PEP's efforts to restore habitats and wildlife around the estuary? You could choose more than one here. We just want to get a feel for what people think is easy to do in helping to combat the issues that we face around the estuary for our habitats and wildlife. Okay, we almost got half people voting. All right, it looks like the votes are stopping, so I am going to close the poll. Share results. So again, we have a tie here for what is the easiest way to participate in PEP's efforts to restore habitats, attending our meetings, events, and workshops to gain knowledge, and continuing partnering with PEP on restoration projects. So a lot of partners on our call today want to continue doing that. And then joining community science monitoring programs to help collect data. So this is great information for us. Thank you. And then the last question for this session is, why is PEP's work important to you? And you can choose more than one choice here. I know we're at 4 o'clock now, so just give a few more seconds. All right, ending that poll. And the top choice here is relying on PEP to bring all stakeholders together to bring science-based solutions to the forefront. This was the top choice amongst all 3 sessions, which is interesting. That's good to know. And then the second choice is rely on PEP to educate and engage communities and rely on us to support monitoring and research programs. So this is great information. Thank you so much, everyone, for participating in that. I am going to pass it back to Matt.
All right.
Now.
That's great. Well, we're pretty tight on time, and so maybe we'll field one question from the audience on this. And I believe you had one that was from Chris Clapp that came in. So maybe you could read that one off, Elizabeth, if you're okay, go ahead.
Got that.
Sure.
So yeah, this question I think is a really great one from Chris Clapp and goes along with some of the what we were discussing here. He said, historically, restoration objectives and goals were written and acted on looking at what was. How do we begin to draft and realize new goals for what will be, knowing how rapidly the environment is changing?
All right. Do we have any takers?
Yeah, I'll jump in on that. Yeah,
Okay.
Question, Chris. It's are we trying to get back to some form of level and in the shifting landscape here? I mean, from the Scallop standpoint, yeah, we want to try to get back to what things were like before 2019, certainly. But it's a shifting baseline now. So how do you reset that? So in our case, we have to do the best we can to reestablish populations in a sustaining population and try to do what we can to moderate population fluctuations to maintain that long term. So it may be a little different in our case than it would be for habitat, for example.
But in a certain sense, Steve, I think that it's the same in that, we're talking about ecosystem manipulation really more than the term restoration when what that refers to. We are targeting a strategic plan to address a particular issue, whether it's keeping the scallop populations, high, or it's, increasing salt marsh presence for future years.
Yeah.
True.
Very true.
But I think that it's those processes. We're trying to restore the natural processes so that these systems can be self-sustaining, and the PEP CLIPS project to identify, where salt marsh has the opportunity. If it's in good shape, where does it have the opportunity to move landward and persist? And it's an operation of triage. And the sports analogy was it Wayne Gretzky who said, "I don't pass the puck to where my partner was. It's where he's going to be."
Mm-hmm.
We definitely have to be looking to the future.
Good analogy. Everybody loves Wayne Gretzky.
At PEP, our policy we're looking for no net loss of wetland, tidal wetlands. And I think that's important to remember. It's inevitable that we will lose some just because, as the sea level rises, then there's no more habitat on that end. But hopefully we can maybe replace that with habitat on the other end. And when I say replace, I don't mean actively build necessarily, but, just creating pathways so that at the end of the day, at the end of the century, we still have this system in existence in New York.
Very good.
I'm sorry.
Go ahead, Brad. No, go.
I've been around Chris Clapp enough to know that, one of his frustrations is how many times we pick restoration goals based on what we want or what our gut tells us. When we did the Seagrass task force, the goal was based on people's, we'd like to have 20% increase, right? Well, that's not very thoughtful or strategic. And I think that the idea of being really realistic about what we might be able to achieve is critically important when we are talking about these particular issues.
I agree, Brad. with the solute transport model and the groundwater, what the whole idea behind that was to be strategic in how you identify high conveyance areas with nitrogen. So you improve water qualities in these very impaired water bodies. It's just, resources are limited, and, it's a race against time. And so, being more focused, and Nicole mentioned this earlier, as Steve, everybody's kind of been alluding to this and stating it. And I think that's going to be what probably comes out of all this panel, is that, being strategic is smart. The better we utilize our resources that are limited, it's just going to benefit the estuary in the most effective way, long-term. So hopefully we can
Matt?
get there. Yes.
And I just, one of the other things we need to consider, and I know that Nature Conservancy is a real proponent of this, is, and so are the people on this panel, but we have the certain resources now, and we need to, so climate change is something that it may be a little bit bigger than we can tackle and turn around on our own, but any kind of small disturbances or impacts to these wetlands that we can protect them from, be it signage for eelgrass meadows so people don't run their boats through them and fragment it, or dig them up, or people, continue ditching of salt marshes. I think we need to protect, again, what we have, and then our plans for restoration or management in the future to try to increase can be based off of what we can hold on to, and then we can move out from there. Because again, it's easier to, those processes, I don't remember who said it, but those systems, the processes in a new system that's restored is not the same. It's not the same value. And we can't get back to that without waiting a long time and putting a lot of money and effort into it. So I think we need to incorporate more protection into our management plans and looking into the future. And I think there's support in the community for that.
Great point, Steve. All right. Well, we've gone over in our time. I think we'll just end the questions here. Maybe we can take them as a group later on for the remaining ones that came in. So I just want to, first of all, thank all of our terrific group panelists. They were just awesome, and it was a lot of fun to work with you all on this and talk about these topics. We know you have a busy schedule, and appreciate you taking your time out of your day for this partnership conference. So thank you again. I also want to thank the PEP Program Office for inviting me to even host this session, and also for doing a tremendous job organizing this whole biennial conference. Not the easiest thing to do in a pandemic, and they did a terrific job, and I thank them for that. And I just want to thank all the participants, the audience today, for showing up, taking the time out of your schedules as well. Your participation is key to helping to move these actions forward. And we look forward to seeing you all in the future. And thank you very much again for everyone for being here. It's been a lot of fun.
Yes, thank you, everyone. And we will try to follow up on any questions that we didn't get answered. But I think we actually answered a lot of our questions through our discussion today. So thank you, guys.
Thank you, everyone, for your
Thank you.
participation.
Yeah, thank you.
Guys,
Have a good weekend, everybody.
you too.
You too.
Thanks.
Me too.
Did a great job, guys.